We will now talk about other measures of location. And here the idea is that we take a data set, and let's say that our data set is the monthly return of a stock over the last 200 months. So we have 200 data points, which means that n is 200. We take this data set and organize it from the lowest number to the highest number. So for example, our lowest number might be minus 7.90%. This would be the number we write first because we want our data in ascending order. So this is the first number, and then we go all the way up to the highest number, which might be 9.55%. So this would be point number 200, since this is the highest number, and in between we have all the other numbers. Quantiles means that we take this data set and split it into smaller pieces. Quantiles is a generic term. So the way you can remember that is quantiles comes from quantity. So we are simply talking about a generic quantity. Now, the specific quantiles that are used most often are shown over here. Quartiles, quintiles, deciles, and percentiles. Now here again, it's easy to understand what each of these terms means. Quartiles comes from quarter. This means that we take our data set and divide the data set into quarters. So we will have the first quartile, then the second quartile, the third quartile, and the fourth quartile. Here we would have the smallest number, and here we would have the largest number. So quartiles means dividing into 4 parts. Quintiles means dividing into 5 parts, and you can remember this based on the term quintet. So a quintet is a group of 5 people. Therefore, quintiles means that we divide into 5 groups. So with a quintile, there is 1, 2, 3, 4, 5. Deciles comes from deci or decimal, which means 10. So if we divide our group into deciles, that means that we will have 10 groups. So from 1 all the way to 10. And percentile is simple. So here we divide our distribution into 100 groups. So each group would represent 1%. So hopefully now you can remember these 4 terms: quartiles for 4, quintiles for 5, deciles for 10, and percentiles basically comes from percent. So we'll discuss these in more detail in point 1, and then point 2 is a small section which deals with how these different types of quantiles are used in investment practice. Now let's go over some important terminology, and the first term here is the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. Going back to the data set that I just described, we have 200 data points, which basically represent the returns over the last 200 months. Let's say that we have sorted this data in ascending order from lowest to highest. Over here, 150, 100, 150, 200 represent the location. So this is the first data point, this is the 50th data point, and so on, after we have sorted the data. Now, the reason I have 50 over here is that this represents 25% of the data. 25% of 200 is 50. This represents 50% of the data. So basically, this is the first quartile. The upper end of the first quartile is this value, 1.95. We can also say that this is the 25th percentile. Then this is the upper end of the second quartile. We can also say that this is the 50th percentile. This is the upper end of the third quartile, which is also the 75th percentile. And then this is the end of the fourth quarter. So if we say that the interquartile range is the difference between the third quartile and the first quartile, this interquartile range would be the range over here. So that's the end of the third quartile. This is the end of the first quartile. So the interquartile range is between 1.95 and 5.39. So that covers the interquartile range. In terms of more terminology, PY is the value at or below which Y% of the observations lie. So if, for example, we say P75, this means that we are talking about the value at or below which 75% of the observations lie. So in our example, that would be 5.93 because this is at the 75th percentile. This is point number 150. So we can say that 5.39 is the value at or below which 75% of the data lies. Now, if you are asked the question, what is the location for the 80th percentile? And the answer will be calculated using this formula. So L here stands for location. So the location of the 80th percentile will be n plus 1. N is the number of data points. In our example, that's 200. So we'll have 201 because we have n plus 1. And then multiplied by y over 100. So if we are looking at the 80th percentile, then this will be 200 into 80 over 100. And that will give us 160.8. So this is the location of the 80th percentile. So here we will find essentially the 160th term, and that will represent the 80th percentile. When our sample size is small, the percentile location that we get using this formula is an approximate number. But as n becomes larger, the answer that we get using this formula becomes more and more precise. When Ly is a whole number, so if we have Ly equal to 75, then the location corresponds to an actual observation. When Ly is not a whole number or not an integer, then Ly lies between the two closest integer numbers, and we use linear interpolation between these two places to determine Py. Now this is actually making a very simple point. For certain percentiles, we might get a location number that's not a whole number. So there might be a certain percentile for which we get Ly is equal to 50.5. So what is the Py value? If we have 50.5, that means that we need to look between location 50 and 51. So if at location 50, the value is 1.95, and at location 51, the value is 2.05, then location 50.5 would mean a value in between these two. So in our simple example, that would be 2.00. So we would say that the value corresponding to location 50.5 is 2.00. Now let's look at this data set to come up with quartiles, quintiles, deciles, and percentiles. The first thing to do is understand this data set. What we are looking at here is daily returns of a stock index over the last 5 years. Now in each year we have 252 trading days. So per year we have 252 daily returns. If this is over a 5-year period, we have 252 into 5, which is 1260 returns. So we have 1260 individual returns. But rather than look at these returns separately, what we want to do is divide these returns into bins or categories. Let's say that we want to divide these returns into 20 bins. So if we divide by 20, we get 63. This means that in each bin, we want 63 observations or 63 return numbers. Now, as we've discussed before, our data needs to be sorted from lowest to highest, which is ascending order. So in bin 1, we will have the smallest numbers. And with each of these bins, we are going to have a lower bound and an upper bound. Let's say with bin 1, our lower bound is this number, minus 4.108, and our upper bound is higher, which is minus 1.416. And then we have a second bin and so on. So each bin represents 5% of the trading days. So this is our data. Now we will go over each of these terms. So remember, quartiles means that we break our data or split our data into quarters. If we have 20 bins, then quartiles would mean going up to bin 5, then bin 10, then bin 15 and bin 20. So the first quartile number would be this one over here, minus 0.293. The second quartile number would be this. The third quartile number would be 0.460. So the interquartile range would be 0.460 minus 293. So 0.460 minus 0.293, and this is 0.753. Visually, we can say that this is the interquartile range. Next, we have quintiles, and I'll show this in green. Remember, quintiles sounds like quintet, which means that we need to split into 5 pieces. If we have 20 bins, 5 pieces means that we have 4 bins each. So 4, 8, and so on. The first quintile would now be this number over here, minus 0.432. The second quintile would be minus 0.07, and so on. For deciles, I'll use black. So deciles means that we split this into 10 parts. With 20 bins, the first decile would be bin 1 and bin 2. So the first decile would correspond to minus 0.876. The second decile would correspond to minus 0.432, and so on. For percentiles, I'll use blue. Now, if you are asked what's the 50th percentile, so the 50th percentile also represents the median. The 50th percentile would basically be the halfway mark. So our 50th percentile will be over here. The 60th percentile would be 0.173, and so on. The box and whisker chart shown over here is one way of visualizing the data across different quartiles. So I'll show you one popular way of depicting a box and whisker chart. The box and whisker chart can actually be shown in multiple ways. What I'm showing here is just one way that is commonly used. So essentially, we divide our data into quarters. So this is the bottom quarter, or Q1 over here. This lowest value is the lowest value of our data, which also represents the lowest value of quarter 1. Then this is the highest value of quarter 1, or the lowest boundary of quarter 2. So this is quartile 2. This is the upper boundary of quartile 2. Then we have quartile 3. So this is the lower boundary of quartile 3, and the upper boundary of quartile 3 is over here, and this is the highest value. Now, before you move on, I want you to look at this data, which is the same as what we had on the previous slide. And I want you to fill in these values, the lowest value, and then these boundaries, and the highest value. You don't need to do the arithmetic mean. So hopefully here's what you got. The lowest value is simply minus 4.108. That's coming from here. This point over here is the lowest boundary for the second quartile. So for the second quartile, the lowest number is this, minus 0.293, which is the same as the highest number for the first quartile. And these two numbers are the same because we are dealing with continuous data. And then our median is 0.044. That's over here. So this is the number in the middle. The upper boundary for the third quartile is 0.460. So our third quartile ends over here. So this is the highest number for our third quartile, 0.460. And then our highest number is over here, 5.001. So this is our box and whisker chart. Now, as I mentioned, there are other ways of presenting this data, and if something like this shows up on the exam, you will be given the specification, and then you just need to use common sense. Here I have shown you the most popular way of coming up with a box and whisker chart. Now I want you to do this practice question. You are given this data set, and I want you to use this formula to find the 75th percentile point. So you need to come up with the location and then the value. So these are actually the values. So hopefully you recognize that the first thing you need to do is sort this data. That's a little bit of work. You just need to do that here in practice. In the exam world, it's unlikely that you will be made to sort data. So pause the video and solve this. So hopefully, here's what you did. Step 1 was to arrange the data in ascending order. So that's done here. Then to find the 75th percentile point, you use the formula. So n plus 1 into 75, which is coming from the 75th percentile, divided by 100. This gives you the 9th value. And remember, since we have a small data set, this is just an approximation. So we will come to the 9th value, which is this one. So P75 is 40. Then first quartile point. First quartile means 25th percentile. So we have L25, same formula. We get the third value, and the third value is 34. Fifth decile, this is the same as the median. So fifth decile is L50. This gives us the sixth value, which is 36. So this is value number 6. So fairly straightforward. You need to remember this formula, which is basically the location of the yth percentile is n plus 1 into y over 100. Based on this, you get the location, and then using that location, you can easily get the value. As I mentioned before, if your location is not a whole number, let's say your location is 6.5, then you look at the 6th number, the 7th number, and then interpolate to come up with a value in between these two. Quantiles are used frequently in investment practice. There are several ways in which quantiles are used. A couple of ways are shown here. When we deal with portfolio performance evaluation, the performance of investment managers is often evaluated in terms of the percentile or quartile in which they fall relative to the performance of their peers. So we can say that here are the top quartile managers. This means that if all managers are divided and we look at the worst performing and the best performing and we divide into 4 groups, then the best performing managers would be in the top quartile. This means that their returns are better than 75% of the managers. So this is one way of using quartiles. In investment research, companies can be ranked based on their market capitalization and sorted into deciles. The first decile contains companies with the smallest market values, and the 10th decile contains companies with the largest market values. Such a classification allows analysts to compare the performance of small companies with large ones.